So we'll start with Maxima and Minima chapter. The exercise is 12C from OPM. Okay. Question number 1. Sub question 1. Exercise 12C, chapter 12, page number 44. I hope you are sitting with the textbook. Find two positive numbers whose sum is 24 and the product is as large as possible. Okay. So let the two numbers be. Let the first number be x. So the second number will be 24 minus x. Whatever is remaining from 24, that will take as the second number, 24 minus x. Now, every maxima and minima problem you might have observed in AOC also. Every maxima and minima problem has an objective. The objective of this problem is to maximize the product. Okay. Objective of the problem. Every maxima minima problem, LPP problem has an objective. So what we have to maximize over here? The product is as large as possible. To maximize product. Now, product of what? Product of certainly the first number and the second number. So I'll just calculate product first. So the product is a very important thing in this particular problem. So product of the first number and the second number, which is equal to 24x minus x square. 24x minus x square. Okay. So this part becomes f of x. Okay. 24x minus x square becomes f of x because we have to maximize the product. So product will become f of x. Why f of x? Because x is there on the right hand side. Okay. So I'll take f of x as 24x minus x cube. F dash x, you know the steps, right? In maxima minima problems, always calculate the first order derivative, that is f dash x, then the second order derivative, that is f double dash x. So the derivative of 24 minus x cube is 24 minus 3x square. Now f double dash x, second order derivative. Okay, derivative of the second order is d by dx of the first order. So the derivative of 24 minus 3x square will be minus 6x. Okay, I don't think so. This thing is very difficult for you to grasp. Okay. 24x minus, oh, sorry, 1 second. Have I made some mistake? Yeah, 24x minus x square. I wrote x cube, sorry. 24x minus x square. And this will be 24 minus 2x. I'm sorry for that. So this will be minus 2. Okay. Now step 1. In every maxima minima problem, we have step 1 and step 2. In step 1, we equate the first order derivative to 0. So 24 minus 2x is equal to 0. So if you solve this, we get the value of x as 12. This is step 1. Fine. Now the product should be maximum. That we need to prove. Without proving, you just cannot write x is equal to 12. So the first part is 12, second part is 24 minus 12, which is equal to 12. We have to show that there is maximum over here. What is maximum, or what has maxima? The product has maxima. Okay, so step 2. Put x equal to 12. Put x equal to 12 in f double dash x. Okay, in f double dash x. Now f double dash x, guys, it is minus 2. Can we put x equal to 12 over here? Ideally, we cannot. Okay, right hand side does not have x term. So I'll comment f double dash x is lesser than 0. Since f double dash x is lesser than 0, f of x has maxima or is maximum. At where? You should always write this. At which point? At x equal to 12. So we need to find out the two positive numbers. So the first number is x, which is equal to 12. Second number is equal to 24 minus x. 24 minus 12, which is equal to 12. Basic problem. Okay. Right. Question number 2. Question number 1, sub question 2. You can take it for self study. It is exactly the same so same problem which is asked in a different manner. Okay. So x plus y is equal to 8. So what is y? If x plus y is equal to 8, what is y? I'll give you the hint for the next problem. So question 2. So how to proceed? See. Question number 1, sub question 2. X plus y is equal to 8. Therefore, y is equal to 8 minus x. Objective. Okay. To maximize xy. Okay. So what is the objective of the problem? To maximize xy over here. It can be either maximize or minimize. Okay. X into y. Now what is x into y? It is x into 8 minus x. It is x into 8 minus x. Okay. So f of x is equal to 8x minus x square. Okay. So this is the starting point. You can take it ahead from here and solve it as self study. Fine. Then calculate f dash x, f double dash x, step number 1, step number 2. Okay. But then towards the end, they are asking maximum value also. So whatever x value you get, that you put in f of x. Whatever x value you get, whatever the value of x that you get, for which the function is maximum, that x value you put it in this f of x. Or you can put it over here also. X into 8 minus x. That will be the maximum value. Okay. Yeah. Next question. Question number 1, sub question 3. Question number 1, sub question 3. Okay. So x plus y is equal to 60. Okay. Objective to maximize. We are supposed to maximize xy cube. Okay. So we need to find out the value of xy cube. Now this time I'll write x in terms of y. 60 minus y. Okay. You can also go ahead with y in terms of x. That is not a problem. You can also write y is equal to 60 minus x. But then this y cube, I have to keep it as it is. I don't want to change this. You can work the other way around also. You can put y as 60 minus x the whole cube. That is not a problem. But then that cube term, I want to keep it simple. Okay. So what is x? X is 60 minus y into y cube. Okay. So this time I'm getting f of y, function in terms of y. 60y cube minus y raised to 4. You can also get in terms of x. That is not a problem. That is absolutely not a problem. So instead of writing f of x, I'm relying on f of y for this problem because the calculations will be a bit simple. Okay. F of x also will be simple. Don't worry about that. But then I'm relying on y. Okay. So we got the value of f of y. Okay. F dash y is 180y square 180y square minus 4y cube. Okay. Then f double dash y. 360y minus 12y square. Minus 12y square. Okay. So step number 1. Yes, I'll just go back to the previous slide. See. Fine. Yes or no? Okay, then calculate f dash y, f double dash y. Step number 1, f dash y equal to 0. So 180y square minus 4y cube equal to 0. Fine. So let's take 4y square common. So this will be 45 minus y equal to 0. Right? Okay. So this implies two things. 4y square equal to 0 or 45 minus y equal to 0. 4y square is equal to 0 or 45 minus y equal to 0. Right? So this implies y equal to 0 or y equal to 45. But then if we take the value of y as 0, if we take the value of y as 0 and if we try to maximize this, if you put y is 0 over here, will you get a maximum value of xy cube then? If you take y value as 0, the entire product will be 0. It won't be a maximum value then, right? So we are discarding the value of y as 0. Okay. If it is a numerical, if it's not a word problem, you can very well take the value of y as 0. But then since this is a word problem, y equal to 0 will have some implication. And what is the implication? If you put y equal to 0 in xy cube, xy cube will also be 0. So that won't be the maximum value of xy cube. Okay. So let's take y equal to 45. Okay. Step 2, put y equal to 45 in f double dash y. F double dash y equal to 360y minus 12y square. So 360 into 45 minus 12 into 45 the whole square. So 360 into 45, we have to calculate that first. Let's do that. 16,200 minus 12 into 45 into 45. 24,300. Okay, so just subtract this. Minus 81,000. 8,100, sorry. Okay. So this is a negative value. F double dash y is negative. F double dash y is less than 0. What does it imply? Do we have a maximum or a minimum? Okay, so we'll write f double dash y is less than 0. Therefore, f of y has maxima or is maximum at y equal to 45. Okay, we don't have to find out the maximum value. We just have to prove it is maximum value is not asked, so no need of putting this y in f of y. Okay, but then they are asking two positive integers, two positive numbers x and y. So if y is equal to 45, x is what? Let us go back to the first slide. 60 minus y. X is 60 minus y. So 60 minus 45, which is equal to 15. So we got the two values, 45 and 15. Okay. Question number 1, sub question 4. Right. Given x into y is equal to 1 and x is greater than 0, x is positive. Okay. So objective, always write down the objective of the problem. To minimize the value of x plus y. So here you can write x in terms of y or y in terms of x. Anything is okay. So I'll just write this as y is equal to 1 upon x. You can also write x is equal to 1 upon y. Okay. So since we have to minimize x plus y, which is given in the problem, first we'll find out the value of x plus y. Okay. So that is x plus 1 upon x. Replace the value of y with 1 upon x. Okay. So f of x is equal to x plus 1 upon x. We got the value of f of x. After calculating the value of f of x, we will calculate the value of f dash x and f double dash x. Okay. So f dash x is equal to 1 plus 1 plus minus 1 upon x square. Okay. I hope you know derivatives, right? Fine. So f double dash x, it is nothing but d by dx of f dash x, the derivative of this. Okay. So derivative of 1 is 0 plus d by dx of minus 1 upon x square. Take that minus outside. Indices x raised to minus 2. So minus 2 x raised to minus 3. X raised to n formula. So this is 2x raised to minus 3. 2 upon x cube. 2 upon x cube. This is f double dash x. Okay. So we got the values of f of x and f double dash x. And f dash x as well. Your derivatives should be strong. There will be easy derivatives, not complicated derivatives. Okay. So step number 1. Step number 1. F dash x is equal to 0. Now what is f dash x? F dash x is this 1 minus 1 upon x square. Plus into minus is minus. So 1 minus 1 upon x square equal to 0. Right? So 1 is equal to 1 upon x square equal to 1, x is equal to root of 1. Root of 1 can be negative or root of 1 can be positive. We'll discard the negative value because x is greater than 0. Okay. So x equal to 1. We got the value of x as 1. Fine. Step number 2. Step number 2. Put x equal to 1 in f double dash x. F double dash x is 2 upon x cube, which we already have calculated. See, f double dash x is 2 upon x cube, right? So put the value of x as 1 over here. So this is 2. F double dash x is greater than 0. Therefore, f of x has minima at x equal to 1. Don't write x equal to 2. 2 was the testing value, greater than or less than 0. At x equal to 1. Now in this problem, they're not asking the values. They're not asking the values of x and y. See, read the problem. They're asking minimum value of x plus y. So since we have got minima, we can get minimum value. So put x equal to 1 in f of x. F of x is what? X plus 1 upon x. Right? So 1 plus 1 upon 1, which is equal to 2. Now this 2 is which value? Can someone tell me? This 2 that we have got, it is which value? 2 is which value? Waiting for your feedback. 2 is x plus y, correct? So that is the minimum value. That is a minimum value of x plus y. It's not the maximum value. It's the minimum value of x plus y. Okay. Let us go to question number 2. Question number 2. Okay. Determine two positive real numbers whose sum is 15 and the sum of whose squares is minimum. So let the two positive real numbers be x and y. Okay. Let two positive real numbers be x and y. So x plus y is equal to 15. Okay, it's given. What is the objective of the problem? Objective, hunt for the objective of the problem in AOC, in this Maxima Minima part, whether it is section 1, section A or section C. Okay, also in the chapter of linear programming, always find out the objective of the problem. The objective of the problem is to minimize. We have to minimize something. Okay, so to minimize what? Sum of squares. Okay, of two real numbers, two positive real numbers, that is x and y. The two real numbers are x and y. So sum of the squares. So that is equal to x square plus y square. X square plus y square. So this x plus y is equal to 15 we can express in terms of x or we can express in terms of y. Not a problem. Anything works. Y is equal to 15 minus x. Now this y is equal to 15 minus x. I am going to put it over here in y. Okay. So the sum is x square plus y square. Put the value of y as 15 minus x. Okay. Just erase a few slides. Wait. Yeah. So we were over here. Sum is equal to x square plus y square. Okay. So x square plus 15 minus x the whole square. This becomes f of x. Now you have a choice to open the brackets over here and simplify or directly derive it. Both the things work. I'll directly derive it. F dash x is equal to 2x. 2 into 15 minus x into d by dx of 15 minus x. So 2x plus 2 into 15 minus x into minus 1. So 2x minus 2 into 15 minus x. Okay. This minus into plus will become minus. Okay. Now we can simplify this further. It's easy. 2x minus 30 plus 2x, that is 4x minus 30. This is f dash x. If you want to expand and solve, if you want to do a minus b the whole square, simplify this and solve that, then also you can do. That's not a problem really. Can someone tell me the value of f double dash x? F double dash x is the derivative of f dash x. So it is 4. Derivative of 4x minus 30 is 4. Once we have calculated f of x, f double dash x, f dash x, f double dash x, rely on step 1 and step 2. Rely on step 1 and step 2. Okay. So step 1, f dash x is equal to 0. 4x minus 30 is equal to 0. Calculate the value of x. So x is equal to 30 upon 4, which is equal to 15 upon 2, which is equal to 15 upon 2. Okay. The value of x is 15 upon 2. Put the value of x in f double dash x. Put x equal to 15 upon 2 in f double dash x. F double dash x is equal to 4. Okay. Now really we cannot put any value of x as 15 by 2 over here. Right hand side does not have the value of x. So this is greater than 0. Directly we can comment. Okay. So f of x has greater than 0. No? So has minima at x is equal to 15 by 2. Okay. Now we don't have to find out the minimum value. We just have to find out two positive real numbers. So the first positive real number is x, which is equal to 15 by 2. Y is equal to 15 minus x. 15 minus 15 by 2. So y is also 15 by 2. So this becomes the final answer. This is the final answer. If they're asking you minimum value as well, then you can put the value of x is equal to 15 by 2 in f of x. Are you understanding the point, everyone? Just give me a feedback. Yes or no? If I take it yes, you have understood this. I'll go to the next problem, question number 3. Okay. Let us go to question number 3. Find two numbers whose sum is 15 and the square of one is multiplied with the cube of the other is maximum. So let the two numbers be x and y. So x plus y is equal to 15. Just wait for expressing x in terms of y or y in terms of x. Just wait for that. Okay. Objective. Now what is the objective? Something has to be maximized. To maximize square of one number, that is x square multiplied into cube of the other number, y cube. So we have to maximize this. Guys, have you understood this? What we have to maximize? You'll understand only after reading the problem. You will understand only after reading the problem. Okay, so the value of this first I will calculate. We have to maximize x square into y cube. So you can write x in terms of y or y in terms of x. For this problem, I want to keep this y cube as it is. So I'll change x. So what is x? 15 minus y. So x is 15 minus y. You can do the other way around also. Okay, you can write y in terms of x also, not a problem. 15 minus y the whole square into y cube. Okay, so this equal to 225. I'll just open the bracket. Minus 30y square, 30y plus y square into y cube. You can also proceed without opening the bracket. That's not a problem really. Minus 30y raised to 4 plus y raised to 5. So instead of writing everything in terms of x, I have written in terms of y. It is your choice. Okay. But then cubing would be a problem. Okay. And the terms will be big. So I relied on changing x to y. So this becomes f of y. This becomes f of y. Okay. Right. F dash y. We have to derivate this. I hope everybody is copying. 225 into 3. 675 y square f dash y 675 y square, okay, minus 120 y cube plus derivative of y raised to 5 is 5y raised to 4. Okay, this is f dash y. I'll go ahead with f double dash y. F double dash y. So what is f double dash y? 675 into 2. 1350y minus 360 y square plus 20 y cube. Guys, are you getting the same values? Please check, because while turning the pages, sometimes, I make errors while copying. Please tell me, are you getting the same thing? Okay, great. After this, what you are supposed to do? Correct. Step number 1, f dash y equal to 0. Okay, so 675 y square minus 120 y cube plus 5y raised to 4 is equal to 0. One thing for certain, y phi is common for all the three terms and y square is also common. So 675 divided by 5. Okay. 135 minus 120 divided by 5. 24y plus y square equal to 0. Now we'll get two things. 5y square is equal to 0 and the quadratic is equal to 0. Quadratic is y square minus 24y plus 135. Okay. 5y square is equal to 0, or the first thing will give you y is equal to 0. Okay. The second thing is quadratic. Y square minus 24y plus 135. Now guys, you have to factorize this. So 15 into 9 is 135. Y minus 15 minus 9, y minus 15 is equal to 0. Y minus 9, y minus 15 is equal to 0. So y equal to 9 or y equal to 15. Okay. Now guys, y cannot be equal to 0. If y equal to 0, and if we put that over here, will this be ever be maximum? Yes or no? No, because the product will be 0. There is no chance of 0 being the maximum thing over here. Okay. Hence we'll take y as 9 or 15. Okay, we have to test for both the values. Now step 2 will have two cases. Step 2 will have two cases. So I'll just write down that. Step 2, case 1. Put y equal to 9 in f double dash y. So f double dash y is this. So f double dash y, I'll just write it down. 1350 into y minus 360y square plus 20y cube. Okay. The problem is lengthy, but then you have calculators along with you, so that's not really a problem. Okay, so 1350 into 9. Let's just calculate that. 12150 minus 360 into 81, 29160 plus 20 into 729. 14580. 14580 plus 12150 minus 29160. So this is negative minus 2430. Okay, this is negative. Therefore, f of y has maxima at y equal to 9. And do we require the maximum value? Yes, we require the maximum value. Right? So as per this case, y is equal to 9. That is the second number. Okay. So the first number, if y is equal to 9, x is equal to 15 minus x. So 15 minus 9, which is equal to 6. So this is case 1 answer, the one which I have written in green. You don't have to find out the maximum value. You just have to find out whether it is maximum or not. You don't have to find out the maximum value altogether. Okay. So guys, this was case one. We have to work on case two as well because we got one more value of y, and that particular value of y is 15. So we have to repeat the same thing for y equal to 15. Case 2, put y equal to 15 in f double dash y. F double dash y is equal to 1350y minus 360y square plus 20y cube. So put the value of y is 15. Calculations are a bit lengthy, but then be alert. And the best part is you have a calculator, so you need not worry about anything. 1350 into 15, 2250, 360 into 15 into 15, that is 81,000. 20 into 15 into 15 into 15, 67,500. Okay, just calculate this. 67,500 plus 20250, okay, minus 81,000, 6750. Now this is greater than 0. Therefore, f of y has minima at y equal to 15. The problem is asking for maxima and we got minima over here. So case 2 is discarded. We cannot consider case 2. So y cannot be 15 since we get minima. Okay, so only case 1 was the answer. And as per case 1, the value of y is 9 and the value of x is, let me go back, 6. Okay, now as per case 2, if you put the value of y as 15, and if you don't want to do all this, you'll get the value of x as 0. X is equal to 15 minus y. Okay, so that way also case 2 doesn't work because the value of x cannot be 0. The product cannot be maximum. But then it's okay if you want to give those reasons or the thing which I have written. Case 2 is discarded. Only case 1 is the answer. And as per case 1, the green colored part, okay, becomes the values of x and y. Let us go to the next problem. That is question number 4. So question number 4. Divide 64 into 2 parts such that the sum of the cubes of the 2 parts is minimum. So we have to break down 64 into 2 parts. So let the first part be x and the second part be y. Okay, and then x plus y is equal to 64. Okay, right? So objective of the problem, something has to be maximized or minimized. Okay, so we have to minimize the sum of the cubes of the 2 parts. To minimize sum of the cubes, sum means addition, cube of the first part, cube of the second part, x cube plus y cube. So here x in terms of y or y in terms of x, both will be okay. y is equal to 64 minus x. I will just write it down. So x cube plus y cube is equal to x cube plus 64 minus x the whole cube. Okay, I'm not going to really uh, simplify this. I'll keep it as it is. So f of x is equal to x cube plus 64 minus x the whole cube. Okay, if you want to simplify, you can simplify. That's really not a problem. But then, I'll just stick to this particular thing. I don't want to waste time in cubing and all. Squaring is still fine. Okay, so I'll calculate the first order derivative of this f dash x. So I'll just write this on the next page. F of x is equal to x cube plus 64 minus x the whole cube. F dash x, 3x square, 3 into 64 minus x square, dy dx of 64 minus x. So 3x square, 3 into 64 minus x the whole square into minus 1. Derivative of 64 minus x is minus 1. 3x square minus 3 into 64 minus x square. 3x square minus 64 into 3. That you can calculate. 192 plus 3x square. So this will be 6x square minus 192. Okay. F dash x. And f double dash x. If you derivate this further, this will be 12x. This will be 12x. Okay. Yeah. So the next step number 1, standard procedure. Standard procedure. Step 1, f dash x is equal to 0. So 6x minus 192 square, I guess. 6x square minus 192 equal to 0. 6x square is equal to 192. X square is equal to 30. X square is equal to 32. Okay. So what is the value of x? I need to go back and check my calculations if I made some error. This is x cube plus, 1 second. Yeah. I took the square inside the bracket. I'm sorry. Thank you for pointing out. Yeah. So this is like this. I'm sorry, guys. Just make these changes. Okay. So this will be square outside. Okay. Just erase this part. Sorry for that. Okay. So this is f dash x. I'll go ahead with f double dash x. Derivative of 3x square is 6x. Okay. 3 will go outside into 2 into 64 minus x, dy dx of 64 minus x. Now dy dx of 64 minus x will be minus 1. So minus minus will be plus 6x plus 6 into 64 minus x. Right? Otherwise, you can just open the square over here. Not a problem. Yes, please check, guys. Are you getting the same thing? Fine. So I'll expand this further. Sorry, I'll proceed further with step one. Step one is f dash x is equal to 0. Now what is f dash x? 3x square minus 3 into 64 minus x the whole square. Equal to 0. Right? Three x square 3 into 64 minus x the whole square. Okay. So cancel out the 3. X square. Now expand this. 64 square 4096 minus 128x plus x square. X square is getting cancelled on both the sides. 128x is equal to 4096. 4096 divided by 128. So x is equal to 32. Okay, I'll show you the previous slide once again. See, f dash x, f double dash x. See what I have written. Okay, then equate f dash x to 0. Look at my calculations, how I am calculating. So guys, can you tell me what is step number 2? Step number 2, anyone? Okay, so step number 2 is put x is equal to 32. Put x equal to 32 in f double dash x. Now f double dash x we have calculated. See, I'll just write down the value. 6x plus 6 into 64 minus x. So put the value of x as 32. Okay. Now 64 into 6. Sorry, 6 into 32. 192. 6 into 32. So 192 plus 192. 3d4. This value is greater than 0. Right? So f of x has minima. We were supposed to prove minimum at x equal to 32. At x equal to 32. Right? Yes or no? Are we supposed to find out the minimum value as well? No. We just have to prove that it is minimum, which we have done. Now we have to divide 64 into two parts. So the first part x is 32. Second part is y. Y is 64 minus x. 64 minus 32, which is equal to 32. So we have separated 64 into two parts. That is 32 and 32. Okay. Question number 5. After this, I'll go to question number 5. What is given in question number 5? The difference between two positive numbers is 10. So x minus y is equal to 10. That's given. Two positive numbers. So x will be the greater number, okay? So the greater number will be x, the smaller number will be y. So something has to be maximized or minimized in the problem. So that I'm going to write down as the objective. Okay. You have to read the problem very clearly. Find the numbers if the square of the greater exceeds twice the square of the smaller by the maximum amount. Okay. So to maximize what? Square of the greater. Okay. Square of the greater, that is x square. Greater number is x because x minus y is equal to 10. So x naturally has to be the greater number. Okay. Minus exceeds means it is more than, minus how much? Two times, twice the square of the smaller. Okay. Are you able to understand this? So we have to maximize this. Right? Just read the problem so that you can understand it better. Square of the greater number is x. Exceeds. So obviously when exceeds is there, we always use a minus sign in between. Okay. It's more than twice the square of the smaller. Two times square of the smaller. Okay. So from the above equation, we can write x in terms of y or y in terms of x. Anything works. So I'll just write y in terms of x. Y is equal to x minus 10. Okay. So x square minus 2y square is equal to x minus 10 the whole square. Sorry, x square minus 2 into x minus 10 the whole square. Now these are squares, so it's okay to play with the expansion. X square minus 20x plus 100. So x square minus 2x square is minus x square plus 40x minus 200. This is your f of x. Guys, just give me feedback. Are you understanding these problems? Are you able to understand this or not? So this is f of x, right? What is the next step? What is the next step? The next step is f dash x, calculation of f dash x. Okay. So f dash x is nothing but the derivative of f of x. So that's minus 2x plus 40 minus 2x plus 40 f double dash x, that is equal to minus 2. F double dash x, that is equal to minus 2. Okay. Step number 1. F dash x is equal to 0. Minus 2x plus 40 is equal to 0. So if you solve this, you'll get the value of x as 20. If you solve this, you'll get the value of x as 20. Okay. Step 2. put x equal to 20 in f double dash x. Okay, so I'll just write it over here. Step 2, put x equal to 20 in f double dash x. Now f double dash x is equal to 2, sorry, minus 2. Can we put 20 over here anywhere? Yes or no? Can we put 20 over here anywhere? Yes or no? Please reply. The answer is no. In minus 2, how can we put 20? So directly we can comment minus 2 is less than 0. Okay. So f of x has, I'll just write down over here. F of x has what? If it is less than 0, then what? Waiting for your response. Maxima, correct. It has maxima at x equal to 20. At x equal to 20. Okay. So we proved maxima. Okay. But then what is required in the problem? What is required in the problem? Are we supposed to find out the maximum value? No. We just have to prove maxima. Okay. So what is required? X and y, the two parts. So x is equal to 20. Put that 20 over here. 20 minus 10 is equal to 20 minus 10 is equal to 10. So y is also equal to 10, or y is equal to 20 minus 10, which is 10. So we got the two parts. Okay. Let us go to question number 6. Fine. Question number 6. Divide the number 4 into two positive numbers such that sum of the square of the first and the cube of the other is minimum. Okay, so we have to split 4 into two parts. So the first part is x, second part is y. So x plus y is equal to 4. Keep it as it is. We'll decide later about x in terms of y or y in terms of x. Something has to be minimum. So objective to minimize what? Sum of the square of the first number, plus cube of the other, y cube. Okay. So we have to minimize this. So this time I don't want to disturb this y cube. I'll keep it as it is. So I'll express x in terms of y. X is equal to 4 minus y. See guys, you can also take y is equal to 4 minus x and replace the value of y in y cube. That's not a problem. Okay. So x square plus y cube is equal to x square plus, sorry, replace the value of x with 4 minus y. So 4 minus y the whole square plus y cube. Okay. So this time we got f of y instead of f of x. You can expand this if you want. Okay. So let's do that. 16 minus 8y plus y square plus y cube. 16 minus 8y plus y square plus y cube. This is f of y. Okay. So guys, f dash y and f double dash y. Okay, so I'll just write f of y on the next page very clearly. F of y cube plus y square, okay, minus 8y plus 16. Fine. F dash y, 3y square plus 2y minus 8. F double dash y, 6y plus 2. Step 1. F dash y is equal to 0. So 3y square plus 2y minus 8 is equal to 0. So it's a quadratic, we'll get two different values of y. Can you tell me the two different values of y by solving? I'll just wait for your answer this time. There are two values of y. Just solve. I'll give you time. Correct. Now many of you are replying. That's very good. 4 by 3 and minus 2. Now I'll discard this value minus 2. Can someone tell me why? I'll discard this value minus 2. I'll discard it because x and y are supposed to be two positive integers, two positive numbers to be precise. Okay, so y cannot be minus 2. Y has to be 4 upon 3. Y has to be 4 upon 3. So put y is equal to 4 upon 3 in f double dash y. That is step 2. So step 2, put y equal to 4 upon 3 in f double dash y. Now what is f double dash y? We got f double dash y is 6y plus 2. So 6 into 4 by 3 plus 2. So 8 plus 2, which is 10, greater than 0. Therefore f of y has minima at y equal to 4 by 3. Okay, we don't have to find out the minimum value. We just have to prove that the sum is minimum, which we have done. So if y is equal to 4 by 3, what is x? You can put the value of x as y is 4 by 3 over here. X is equal to 4 minus 4 by 3. 12 minus 4 by 3, which is equal to 8 by 3. So x is equal to 4 by 3, y is equal to 8 by 3. Okay. Are you able to understand this? Yes or no? Just give me a feedback on the first 6 problems. Have you understood all the 6 problems? Hello. Expecting your reward, waiting for it. Yeah. So let us go to the seventh problem, question number 7. Okay. Now the nature of the problem changes. First six were of a separate category. Okay. Find the shortest distance of the point 0, comma c from the parabola y is equal to x square, where c lies between 0 and 5. Okay, including 0 and 5. So we have a parabola. Parabola is a curve. Okay. And there is one point 0, comma c. So we have to find out this shortest distance. This shortest distance. So this d has to be minimum. Okay. So the parabola is y is equal to x square. Parabola is a curve. Point is 0, comma c. So they're asking find the shortest distance. So we have to minimize the distance over here. We have to minimize the distance. Guys, are you able to understand the problem? Are you understand what is supposed to be minimized? I'll go very slow with this, but then, you know, things should be clear. Just waiting for your feedback. We have a point, we have a curve. The distance between the point and the curve, d should be small. D can be large also. See, this also can be d, but then we cannot take this d as d. We cannot take this distance as d because it will be not shortest. We have to find out the shortest distance. Okay. So let the point on the curve be x comma y. Let the point on the curve be x comma y. Okay. So what is d as per distance formula? Root of x minus 0 the whole square plus y minus c the whole square. Guys, have you understood this? As per the distance formula, d is equal to square root of x minus 0 the whole square plus y minus c the whole square. Okay. So d square, take the root on the other side. X minus 0 is x. X square plus y minus c the whole square. Okay. Now, do we know the value of x square, guys? Do we know the value of x square? Somewhere in this slide only it is there. Do we know the value of x square? Yes. The value of x square is y. So d square is equal to y plus y minus c the whole square. Okay. I hope you are copying simultaneously. Fine. So d square is equal to, next step, I'm going to simplify this further. Y plus y minus c the whole square. I just copied this again for you from the previous slide. See, I'm purposely going slow so that you can understand. Okay. Now I'm going to expand that square. D square is equal to y square minus 2cy plus c square. Okay. So this is the value of d square. Objective. The distance should be shortest. Meaning of shortest is minimum. So to minimize d, to minimize d. This is the objective of the problem. The distance should be shortest. The distance should be minimum. Distance of what? Distance from the point to the curve. Now this implies one more thing. To minimize d implies minimize d square. So if we are minimizing or maximizing a value, it implies we are minimizing or maximizing the square of that particular value also. Okay. So this you have to remember. And if you really don't want to do this, then you will have to play with the root. If you don't want to write that step, minimize d square, then unfortunately you will have to incorporate root in the solution, which is not advisable. Okay. So d square is what? Y plus y square minus 2cy plus c square. So this becomes your f of y. Y plus y square minus 2cy plus c square. Okay. Now the next few steps are very simple for you. Okay. F dash y, f double dash y, that you can do. F dash y, f double dash y. So f dash y, 1 plus 2y minus, okay, derivative of y with respect to y is 1. We are differentiating with respect to y, not with respect to x. So don't allow chain rule to occur over here. 2y will be 2y only. Don't write dy dx of y, because we are differentiating with respect to y, not x. So 1 plus 2y minus 2c plus 0. Okay, just a second. Okay, so this is f dash y, f double dash y. Okay, so this will be 2, because derivative of 1 is 0, derivative of minus 2c is 0. Fine. Step 1, f dash y equal to 0. So 1 plus 2y minus 2c is equal to 0. 2y is equal to 2c minus 1. Okay. So y is equal to 2c minus 1 upon 2. We got the value of y. Fine. Now where to put this value? Where to put this value of y? In f double dash y. Correct. Step 2. Put y is equal to 2c minus 1 upon 2 in f double dash y. F double dash y is 2, which is greater than 0. We can't really put this value anywhere in y. Okay, f double dash y. So directly we can comment it is greater than 0. Therefore, f of y has minima. At y is equal to 2c minus 1 upon 2. Okay. They are asking what is the shortest distance. Okay. Right. So they're asking D. They're asking D. Okay. Minima we have proved. The distance is sorted. That we have proved. Okay. Now see, y is equal to x square. Therefore, 2c minus 2, 1 upon 2 is equal to x square. Therefore, what is x? Square root of 2c minus 1 upon 2. We got the value of x. So we got a point also, x comma y. We got the point. But then still the answer is not yet over. We need to find out D. So what is D? Okay, D is this. So I'll just take a new slide and write D equal to square root of x square plus y minus c the whole square. See, now the value of y, sorry, the value of x square. Okay. Otherwise, what you can do is, 1 second. Yeah. So put x square as y, leave it. We'll just do it this way. Y plus y square minus 2cy plus c square. Fine. Okay. 1 second, 1 second. You just put the value of y at this particular point of time. That will be more easy. What is y? 2c minus 1 by 2 the whole square. Now this will simplify. Okay. See, x square is y. X square is y. It's given in the problem. X square equal to y, and that we used also somewhere. Okay. And then put the value of y as 2c minus 1 upon 2. Yeah. So if we simplify this box bracket, so this will be root of 2c minus 1 upon 2. Fine. So this 2 will go over here. 2c minus 1 minus 2c. LCM I have taken upon 2. 2c minus 1 upon 2 plus 2c 2c gone. So this will be 1 upon 4. Again take LCM. Okay. So I have taken LCM over here. Fine. 4c minus 2 plus 1 upon 4. Okay. So D will be root of 4c minus 1 upon 4. Okay. So that is the final value of D. This is what is asked. Fine. Now we'll proceed with the last problem for the day. Question number 8. Okay. The problem is similar. Question number 8. Yeah. The curve is y is equal to 1 by 4 x square plus 1. Okay. The point is 0 comma 6, and this distance should be nearest to the curve. Okay. So the point on the curve will be, anyone? Can you tell me what should we take the point on the curve as? This is related to the previous problem itself. X comma y, correct. X comma y. Okay. So distance d is square root of, the distance has to be nearest, shortest. So d will be square root of x minus 0 the whole square plus y minus 6 the whole square. Distance formula. X minus 0 the whole square plus y minus 6 the whole square. So d square x square plus y minus 6 the whole square. Okay. Now guys, we know the value of x square somewhere in the problem. We know the value of x square. See? Okay. So from here we are going to get the value of x square. So y minus 1 is equal to x square upon 4. So x square is equal to 4 into y minus 1. Fine. So d square is equal to 4 into y minus 1. Right? Okay. So d square is equal to 4y minus 4 plus y square minus 12y plus 36. D square is equal to 4y square minus 16y, sorry, minus 8y. Okay. Y square minus 8y plus 40. Is this correct? No. 36 minus 4 is 32. Fine. Guys, are you getting the same thing? Okay. So see, I'll take you back. I'm writing x in terms of y. Okay. So this 1 will go over here. Y minus 1 x square upon 4, cross multiply 4, 4 into y minus 1. So the value of x square is 4 into y minus 1. Okay. See, you can also replace the value of y. I replace the value of x square over here. You can also replace the value of y. Okay. That's not really a problem. Okay. So now this is the value of d square. It is f dash y square minus 8y plus 32. If you're taking everything in terms of x, it won't be this simple. I'm very much sure about it. See, this is f of y, sorry, this is f of y. Then f dash y, 2y minus 4. Okay, f double dash y is equal to 2. 2y minus 8, 2y minus 8, sorry. Okay, Step 1, f dash y equal to 0. Okay, so the value of y is 4. Value of y is 4. Now where to put the value of y as 4, y equal to 4 as? Where to put this particular value? You have to put this particular value in f double dash y. Step 2, put y equal to 4 in f double dash y. Now f double dash y is equal to 2. We cannot put 4 anywhere over here greater than 0. Therefore, f of y has minima. We proved minimum at y equal to 4. Now this time we don't have to calculate d. We can also calculate d, not a problem, but then they're asking you the points on the curve. Point or points on the curve. Okay. So put the value of y in the curve. Put y equal to 4 in curve. Y is equal to x square by 4 plus 1, right? So 4 is equal to, so 4 minus 1, 3 is equal to x square by 4. X square equal to 12. X is equal to root 12. Now this is a point, it can be positive, negative. So this is 2 into 2 into 3. So x is equal to plus or minus 2 root 3. So this time we are not getting point, but then we are getting points on the curve. Okay. So the curve may be something like this. And this will be the distance. Shortest distance. Okay. Just for your understanding, I'm telling you. It is not required. Okay. So there are 2 points. So the point on the curve is x comma y, but then there are 2 values of x. Okay. X comma y, 2 root 3 comma 4 or minus 2 root 3 comma 4. These are the points on the curve. Guys, any feedback? Okay. I'll give you one extra problem for self-study. Just listen to that. You can solve it as self-study. That is question number 21, which is based on the same concept. Same exercise, same concept. So this is for self-study. The enemy vehicle is moving along a curve. So vehicle is moving along this. Okay, so this is the curve. Artillery is located at 3, 2. Okay, this is the point, and this distance should be shortest. Okay, find the shortest distance between the vehicle and the artillery. Vehicle is moving along this curve. So this is the point. This is x comma y. Okay, so from this you have to calculate the value of the coordinates x comma y, and you have to prove minima also, the shortest distance. D has to be minimized. Isn't it the same problem? Question number 21, is it the same as question number 8? Isn't question number 21 same as question number 8? Yes or no? Just give me a feedback. Yes or no? Fine. So that is the end of session number 1 on exercise 12C, Maxima and Minima. Okay, thank you.